have a master's degree. And think, oh, you're gonna, well, but let's get the cheaper guy who just has a CA. Yeah, who will do anything for 80K. Yeah. But and honestly, like I don't think that's true. To go through job searching, it's over.
I know, but we don't have
No.
we already got it. Like,
No,
until- yeah.
I know.
Be so confident.
Maybe a sudden moment not to the next time, so you guys have all the years.
Don't say
No,
They're not.
I mean,
I feel like that.
oh my God.
Thank you, brother.
I didn't.
Okay.
Made them for a small more than.
Oh my god, that was giving me a headache. I'm gonna retry it. For some reason, it feels so good. This is so bad. You're going back to 60.
All right, it's 5:30. Let's go and get started. All right, good evening, everyone. How's everyone doing today?
Good.
Staying dry, hopefully. It's been suddenly very rainy, but it's good. We can always rain is always a welcome sight in Southern California. All right, so today is ANSYS activity 4. Today's a little bit of a lengthy one, and so a bit longer than activity 3, but this one's really cool. This is where we're actually get to see shell and beam elements actually put in. What we're going to be doing is we're going to be simulating a bridge here, okay? And I picked this geometry because this bridge has a lot of aspects or a lot of parts of the geometry that are lend itself very well to shells and beams. And so, yeah, we're going to be doing that. We're going to be transforming this geometry into shells and beams using the operations that we talked about on Tuesday, and then running the simulation, and then. All right, any questions I can answer before we get started for today? Okay, all right, so let's go ahead and get started. All right, so if you haven't opened up Workbench, go ahead and do that. Go ahead and download the CAD file for this activities too. So it's bridges.iges. So for this one, there's only one CAD file, so there's no extra activity at the end. We're just gonna be focusing on. All right, so let's open up Workbench. Just like we usually do, let's go ahead and add a static structural. So I'm just going to go ahead and double click that. Our workspace. And then let's import our CAD file like we usually do. I click on geometry, let's import the geometry. Browse, and we want this bridges.ignes. Okay, so the part should import pretty easily for. Okay, so this activity is going to be a little bit different because we're actually going to spend the majority of our time working on the CAD file rather than within ANSYS Mechanical itself. Okay, so like we discussed in activity 1, ANSYS actually does come with its own CAD programs. They're not as intuitive and they're not as I would say useful as SolidWorks, but you know. When there are applications when you do need to change your geometry, or maybe you're setting up a simulation strictly for finite elements, you can use the CAD program that it does itself. Okay. Okay, so to modify the geometry here, we're going to right-click on geometry, and you'll see that there's actually 3 different programs for us to have. So there's Design Modeler, which is kind of the OG CAD program. That's the one we use. The new shiny CAD program that they just unveiled just this past year is called Discovery. So I actually don't have any experience in Discovery at all. That's something that's relatively new. But the one that we're actually going to use today is called SpaceClaim. So SpaceClaim is another CAD software, and what it does specifically well is that it works really well in modifying and preparing geometry for finite analysis. Which is exactly what. So go ahead and click on Edit Geometry in SpaceClaim, and so that's going to open up another window. Time. It's taking a lot of time. Oh. Okay. So this is SpaceClaim. So you can see when you compare it to Design Modeler, the program you use 51, the interface is a little bit more modern. So there's pictures for things, and kind of the toolbox, the toolbar looks a bit more modern as well. Okay. And then if you loaded your geometry in, you should see your bridge geometry. A little bit about the controls. So the controls in SpaceClaim are very similar to ANSYS, the other parts. So if you hold down the middle click, you can kind of rotate around the figure itself. If you hold Control and then middle click on your mouse, you can hand back the figure. And you know what we're going to be doing in here is we're going to be basically preparing this geometry by converting it into shells and. Okay. But the first thing we're going to do is we're going to kind of repair any kind of obvious errors in the CAD file. Remember, we talked before that usually, when a CAD file is produced, by an engineering company, it's usually not produced with finite elements in mind. So it's either produced just for design purposes or manufacturing purposes, but a CAD file that's used with finite elements usually has some other requirements. That may not come across in it. First thing we'll do is we're going to repair. Okay, so we're going to click on repair at the top here, and so you can see here that there are multiple tools here for repairing the geometry. Okay? So the one we're going to use here is called Stitch. Okay? And so you can mouse over, you can kind of see what it does. And so Stitch will basically stitch single surfaces together into a single body. So if there's any kind of weird gaps or any kind of weird, things are mostly gaps in your geometry, this is going to fix that up. Okay. All right, so after you click on a repair tool, what you're going to see here is that there's going to be a green check mark that appears in the project workspace here. So it's grayed out right now because SpaceClaim was not able to find any parts of this geometry that are needing fixing. Okay, so it's grayed out. But if there were anything that SpaceClaim did find, this would be highlighted green. All right, another thing we can check here is gaps, and so that's kind of another tool to fix any gaps. Okay. And so you can see here that there is one gap in the geometry here. You can click this check mark to try to fix it. Although this part of the geometry here is actually a little bit special. So you're actually not gonna be able to fix it this time. But just know that, if you do have any weird gaps in your geometry, you can use either one of those tools to kind of fix it up before you run some. Because a lot of times, any of these weird gaps or any of these kind of weird surfaces, they can kind of provide a hindrance to your FEA, especially in the meshing step. And so you want to get those taken care of before you run it. The reason you can't fix this gap right here is that this gap is kind of an artifact of the CAD model itself. What you're going to see is that this CAD model is actually not the cleanest model. This person didn't do a great job, cleaning it up and dimensioning it well. And so, there's actually going to be a lot of things. But the reason I have this here is to kind of illustrate to you that, not every time your CAD model is going to be clean. So you're going to have to do some things like this to clean. The models that I gave you guys for the midterm project should be pretty clean, but that doesn't mean that that you can't fix it. All right, any questions on this? Okay, all right. So now that our model here is relatively clean, let's go ahead and start working on converting it. Okay. If you look at this geometry here, you can see there's a lot of aspects of the geometry that we shells and beams. So first, kind of the most obvious one is we have this road. This road is this kind of very thin, kind of black sheet here. And so this is one that we can convert to a shell. In fact, it almost looks like a shell already. Okay. Very thin geometry. We have all of these supporting beams, and so all of these supporting beams are literally beam-like geometries, and so we can convert those to beams as well. And then the sides of the bridge as well, since these are both kind of parallel, thin structures, we're going to convert these into shells. Okay, so to start converting a geometry into shells, you're going to go and click on the Prepare tab in the top of the screen. Okay. And so this Prepare tab has a lot of different tools that you can use, modify and kind of alter the geometry for better. Okay. In particular, we're going to be using a tool here called the mid-surface operation, which is what we talked about on. Grayed out for now just because I'm away from the window, but 1 second. Okay. All right, so go ahead and click on mid-surface. And we want to turn, we're going to use this mid-surface to turn certain parts of this geometry into shell. Let's start with the road, because that's the most obvious. So if you remember the way the mid-surface operation works, is that we need to select two faces that are perfectly parallel to each other and are separated by a constant distance. And so if we click on the top surface of the road, and then we then click on the bottom surface of the road, you can see here that this mid-surface was successful in kind of finding these two surfaces to be parallel to each other. So if you did this right, one surface should be blue, the other surface should be green. Okay. This tells you that these two surfaces can be eliminated in terms and turn into a shell. And so when you're ready, go ahead and click on the green check mark here. And so that's going to turn this road into a shell. And so to kind of illustrate to you that it did turn into a shell, you can see here that it's kind of turned trend. Although it's a little bit hard to see that the thickness was off. The road was so thin. Okay. Any questions on that? Everyone able to turn that into a shell? Yes.
So when you turn something into a shell, would it be neglected in the analysis?
No, so we are going to include it in the analysis. It's just going to be meshed with a special shell element instead of a typical tetrahedron. Yeah. The point is, because this road was so thin, if we tried to mesh it with tetrahedron, we would have a really hard time meshing it.
So basically, we show some geometry for easier to mesh.
Exactly. Exactly. Yeah. We're going to turn other parts of this geometry to shells as well. Any other questions on this? Okay, all right, so let's go ahead and work on the sides of the bridge. And so the sides of the bridge, we can also turn into shells as well, okay? So with the mid-surface operator still active, go ahead and click on one, maybe the inside surface of the bridge, okay? And then scroll around and click on the outside surface of the bridge, the one that's perfectly parallel to it. So once again, you're going to see that both surfaces are going to highlight. So one's going to be blue. Okay. This tells you that ANSYS was able to find that these two surfaces were indeed parallel to each other and separated by a constant distance. All right, so with both of those surfaces highlighted, go ahead and click on the green check mark. You can see here that those the thickness of that side of the bridge is eliminated, and what we have now is a shell. Okay. Very, very. Which again, now that we've turned this into a shell, when we go to mesh this, we can mesh it with 2D elements, which are going to be much more efficient to mesh than trying to put. All right, and then the last place where we're going to apply the mid surface is the other side of the bridge. So just like we did on the other side, click on the inside surface, outside surface, or if you want to go outside surface, inside surface, doesn't really matter, as long as you kind of click both. Okay, both are highlighted, so one's blue, one's green, so that means you're good to go. Okay. We'll click the green check mark. See now that side of the bridge is now shell. Okay, so you should have 3 mid surfaces here. So you should have one for the road and one for each side of the bridge, and one for the left side. Everyone able to get that in their geometries? Good. Okay. Here are my sketches here. Okay, so next part of the geometry that we're going to work with are the beams. So you can see here we have quite a few beams here. Remember, a beam is characterized as a geometry that's much longer than it is wide. So all of these beams here kind of fit that criteria of one dimension that's much greater than the others. Okay? And so we want to extract these into beam elements. So to do beam extraction is very simple. So once again, we're going to be in the Prepare tab, and then we're going to use this tool right here called Extract. So it's a little bit smaller, and so it's a little bit harder to see, but there's a button there for it. Go ahead and click on that tool. So clicking on the Extract tool will make it active for you to kind of put things around the model. And with the Extract tool clicked, go ahead and click on each individual beam that we have here. So we'll start at the top. Right, so you can see after we click on the beam, we've turned it into essentially just a line. And we're going to do that for all of the bottom beams as well. Careful where you click. If you're like me and kind of misclick a lot, then okay. And so with that, our geometry here is converted. So we put everything, all the aspects of this geometry here into shells and beams. Okay, so at this point, you might think like, all right, we are good to go. So now we can take this and we can mesh it. Well, not quite. Let me show you an issue. So by turning this geometry into shells and beams, we are going to make our mesh a lot more efficient, but we did lose some geometric accuracy here as well. Okay? Right. Most notably, if you zoom into this gap in between the road and the bridge, right? There shouldn't be a gap here because the road should be attached to the bridge. Right? Right? So we need to fix this. And so by basically using a mid-surface operation, we've kind of broken our model at the same time. So if we try to simulate this, those parts are not going to be connected, and then we're going to get a road that just does its own thing. And you can say the same thing for all the beams as well. So you can see all the beams, none of them are attached to the bridge as it's. Okay, so we need to fix this geometry. We need to kind of reconnect things. And this is very common. So, when you do shell and beam analysis, shell and beam elements, and you're doing it and you're converting an existing CAD model, this is something that always happens. So you need to make sure that everything kind of reconnects as it were. Okay. Okay. So the tool that we're going to use here is called the Extend tool. And so what the Extend tool is going to do is that it's going to find geometries here that are not properly connected to the main one, and then extend their length until they are. Okay. So once again, we're going to be in the Prepare tab. And then the extend tool is right here. Okay, so let's go ahead and click on extend. And you're going to see right now, nothing is really highlighted because, you know, the extend tool only works up to a certain threshold of distance, okay? That threshold is given by this number right here. So this is the maximum amount of space or maximum distance that the extend tool will work. Right now, it's only 10 millimeters, which is okay. So let's go ahead and extend this. And so instead of 10 millimeters, let's change it to 50. Right, so change it to 50, hit enter on the keyboard. And you can see now we have you know, quite a few areas here that are going to be extended. Okay, so you can see that they're highlighted with this kind of, you know, orange bubble here, red bubble. Okay, so to apply the extend tool, you're going to go ahead and click on the green check mark. But I'm going to go ahead and change my view here just so that you can kind of see what. Okay, so you can see right now, one thing that we need to extend are these beams because they are no longer connected to the bridge. But you can see right when I click the green check mark, you can see that one of the sides here was extended in the bridge. And you can click the green check mark again, and then now the other side of the bridge will be connected. Okay. And so through that extend tool, you know, we were able to reconnect these beams to the bridge, you know, as they were designed to be. Okay. Any questions on this? Everyone able to run the extend tool on their geometry? Yeah. Yeah. So that's the thing with this geometry. So if you notice, not all the beams were extended into the bridge. So there's quite a few here that are still kind of floating. And the road itself, you can see, is still floating as well. So there's still quite a few issues here. Okay. So remember I said in the beginning that this CAD model was not the cleanest model that's developed. You can kind of see here why. And so you can see I've changed the view. And so if you change the view, you click on the Z-axis here, you can go either. Right? You can see that some of these beams are actually not even, you know, within the same plane as the bridge here. So there's actually a gap up here, which before in the original geometry was fine because all these beams had thickness to them. They had their cross section, and so, you know, it wasn't really apparent that they were kind of misaligned. But now that we've kind of eliminated that cross section, we've eliminated that thickness, you know, now it becomes a lot more clear that not all of these beams were mentioned properly. This could happen sometimes in your when you're doing these things. And so, you know, if you're using this CAD model just for visualization, you know, something like this could be, you know, acceptable. Or I would say, you know, maybe people notice this, but since we're running FEA on this, something like a small error like this is something that's important. So we're going to need to do two things. And so one thing we're going to need to do is we're going to need to move this beam back into position. So we're going to move it up a little bit so that it intersects with the bridge. And then we're going to run the extend tool again in order to extend it to the side of the bridge. Okay. But right now, the extend tool is not working because if ANSYS were to extend this, it would not be able to contact anything. It would just be able to just run off into infinity. You know, that beam is just kind of floating. Okay, so this is going to be the first time where we're actually going to make kind of actually some fairly big changes to the geometry. Okay, so to move a part of your geometry, you're going to go to the design tab up here. So this design tab is you know what you're going to use whenever you need to make, you know, fairly large changes to your geometry. Okay. And you can see here that there's a tool called Move. And so what this Move tool is going to do is it's going to allow you to grab certain parts of your geometry and translate them up and down, which is exactly what we want. And so, you know, for these beams, we just need to move them slightly up in the Y direction, just enough so that they kind of intersect within the plane of the bridge. But we're not going to do that just yet because we need to measure and kind of see how much we need to actually move it up by. So we're going to use the measure tool for this. And so if you go up here, We're gonna just use the main measuring tool here. So this measuring tool here will let you measure certain things that you click on within the geometry. Let's go ahead and click on measure here. And what we want to do is we want to find out how much off are we? So how much do we need to move these beams upwards until they kind of intersect with this bottom edge? So what's going to be helpful is that is to kind of highlight this object here, because we don't want just the raw distance in between this beam and the bridge. We want to find out exactly what the vertical distance is. So to help with that, go ahead and click this check mark here for show XYZ vectors, just so that you can see the exact XYZ distance between the beam. Okay, so to use the measuring tool, we need to select both the beams. So I'm going to go ahead and click on itself. Okay. So first of all, this measure tool is telling you how long the beam is. So it's about 6/35 meters. But we want to measure the distance between this beam and the lower edge of the bridge itself. To do that, you're going to hold down Control on the keyboard. This is going to allow you to select multiple things in your geometry. And you want to select just the bottom edge of the bridge. So you want to be careful. Don't select the whole bridge itself, but just that bottom edge. Now, depending on which beam that you selected, the distance might be different. That's kind of what's sloppy about this CAD file, is that all the beams have a slightly different vertical distance. And so this beam in particular is off by almost about 1.92. And so what we need to do, this is telling us that we need to move this beam upwards about 1. And again, if you selected the exact same beam as me, then you should see that distance be 1.922. But if you selected a different beam, then you're going to get a different. Notice how I rounded up, and so we want to move this beam up enough so that it's intersecting with the bridge. And so instead of moving it up 1.92, I'm going to move it up 1.9. Okay. So with that, let's go back to the design tab and let's go ahead. Let me off click this. You want to be careful here, because when you click on move, it's gonna move whatever you have selected. So you want to off click just so that you're not moving the bottom of the bridge either. Okay, so after you make sure that nothing here is selected, go ahead and click on move. Okay. Go ahead and click on the beam that you were looking at before. So after you click on that beam, these arrows are going to show up here, which are going to allow you to move it in the direction. You can also rotate it. But we want to move this beam vertically upwards. So go ahead and click on this arrow. And unfortunately, these controls are a little bit annoying, because it would be nice to kind of put this vertical distance. But the way to work this is to kind of click on this arrow and just move it up just a little bit with your mouse. Okay. And you're going to see here that we can start to move it up by a certain distance, and that distance is actually shown on the screen itself. Okay. So it doesn't matter. It's if you want, you can try to use your mouse to kind of put the exact location, but that's really hard. So I'm just going to move it up by about 2.45, and then in my keyboard, I'm going to manually put in 1.9. I'm going to hit enter just to kind of finalize that. Okay, so we've gone ahead and moved that beam upwards just a smidge, just by 2 millimeters. So we can go back here, go back to the prepare tab, go to extend. You can see now that beam that we moved upwards is now in line with the bridge. And so we can now extend it just like we did the other ones. Okay, click on the check mark. Click it again. And now that beam is connected as it. Okay, any questions on that whole process there? Okay, all right, so there are quite a few other beams for you to do this with, so I'm going to go ahead and give you guys the next 10 minutes to do that. So go ahead and apply that same process to the other 3 beams. Yeah, so there should be 3 more that aren't connected. And then we'll touch base maybe a little bit after. Okay. If you have questions about anything, just raise your hand. I'll come around to you. Yes. Yeah. So for the beams, that you can't really do a method for that. I think they changed that in the recent version of ANSYS. So it's just by default, so there's only one shape for a 1D element, it's just a line, and I think by default it uses quadratic. Yeah, you shouldn't, you shouldn't.
Sizing.
Yeah, so you should be able to do a sizing object, so sizing you can do for. Yeah.
Whenever I go.
Yep.
It goes.
Oh.
I'm on the line.
Go ahead and control Z a few times. Let's go ahead. Okay, so go ahead and, oh, so we want to get the extent, so go ahead and click the green check once again. Okay. All right, so yeah, let's do a design.
Yes, because you're literally controlling.
So that means that this one spot.
Yeah, I think that's what I was.
Oh, okay, yeah, so if it's already connected, then you don't have to, vote. So we're only doing this for the one thing. If you don't want on the very. There. Yeah.
Yeah. It's really.
Yeah. It should be. Go ahead and hit control again. Let me see the measuring. Why? Not sure why we did this. I think it looks like you put another thing to kind of have this. But the way I just kind of click and drag here. But yeah, I don't know if when you click that, that button, it kind of messes up. This should. Yeah. Yeah, so I would just kind of click the arrow. Just.
Okay.
Oh, so you might have just so the beam, you might have just clicked on one edge of the beam side.
Oh.
Yeah, so you have to select around the whole. You can control it and just not do that. Oh, okay. You want to make sure that when you're moving, don't have the bottom edge of the bridge selected. Because that's going to move that one too. Yeah. What's up? Yeah. Yeah, so first thing you have to kind of put it off. You want to make sure you right now you put the bottom of that. Go ahead and click next. Okay, now click on all. And then click on it. No, just the yeah.
I would want that.
Yeah.
Oh, so you want to select, so you. Like you select.
Yeah, so it's the same that like. Your first click versus negative, whatever.
That one's already connected. Second, that one. That one should. Oh, yeah, the whole control. Yeah, so you can see this one's off by that. 0.41. So that being Yep. Well, first click off because you want to make sure, yeah, you want to have to. Yep.
What's in there?
0.4.
It's,
Yes. Good. I'm going to go ahead and put that there. Prepare. And then extend. And then you go. So those ones. We're going to need that for. A little tedious, but. Okay, good.
Failed.
Yeah.
Let's try doing it. It could be that the beams are. See what it's doing. So what it's seeing is that it's trying to turn this into a beam, but it's seeing as a trying to turn from beam this way because it's technically has to be. Because normally you would expect, you would make a beam. But because this is like a this one, I'm not sure why. Otherwise, trying to create a beam. Just the fact that it made beams very cool. Yep, I would do all the main surfaces. Yeah, good beams, right? Oh yeah, we are going to do the road, but the road's going to be similar. So if you've done all the beams, go ahead and measure the distance between the road and the bottom edge. So we're going to need to move the brick. We're going to need to move the. Or what's it called? I would do the bottom edge because the road is supposed to be resting on. You guys doing on Zoom? Any questions from? Yeah, actually, so someone had that same issue too. So what's happening with that is that it's for some reason Space Claim is thinking that basically whenever you create a beam, it looks for a section of geometry with the consistent shape. And, technically, if you measure the beam from this side to this side, that's the cross-sectional shape that we want. But because the beams are rectangular, actually, if you look at the beam from this way downwards, it's technically a consistent shape as well. So I've actually never seen that before. So having the person in class just kind of restart space claim and restart ANSYS and see if that fixes it. But I'm going to see if there's any settings up here. Basically, we want to enforce it so that it should be not
I don't remember this one. We can try.
When you get to extending the road, should both sides be making contact?
Yeah, so all the sides of the beam should be making contact. We haven't done the road yet, but if we've already got all the road needs to be moved down and so that it makes contact with the side.
Okay.
Okay. And then I'm doing this. Now. Didn't count from that area.
Okay, so if you've already connected all the beams, let's go ahead and move the road down. So we're going to use the same method here. So we're going to measure. We're going to measure from the road down to the bottom. I move it down to the bottom edge because ideally the road should be making contact. It should be resting on top of all the beams. Okay. Okay, so using the measure tool, and everyone should be the same for this because everyone has the same cap lines. But you can see here that the distance we need to move it down is about 28.37 millimeters. Okay. Okay, so let's go ahead and click off. Let's go ahead and click on move the road down 28.37. Okay, so once you move the road down, you're going to use the same extend tool. So go to prepare extend, and you can see that the sides of the road are going to highlight now. Okay, and we're going to connect it to the edge of the bridge just like that. Okay. Okay, so if you're able to get to the geometry, at this point, go ahead and close space plane and go back to workbench and open up mechanical. Okay, so go double click on model. Just because I want to figure out this beam thing for these people, so I'm going to let you guys kind of continue on from here. So the next step in this process is going to be to set the connections. So if you remember from activity 3, whenever you have multiple parts in an assembly, you have to define how those parts connect, right? So in activity 3, that was done for us because that assembly was kind of already designed as an assembly. But whenever you create shells and beams, it kind of breaks apart your entire geometry. So you need to kind of set your connections manually. And so if you go to the project specifications, if you go down to page. This page here, okay? So this kind of describes to you kind of how you can set those connections, so. Yeah, so just I want to kind of go around, get everyone on the same page. I'm gonna go ahead and let you guys do this part, but we'll come back together in hopefully maybe about 15 minutes to kind of do this connection part together, okay? But if you're able to get to geometry, great. If not, just raise your hand, I'll come around, and keep this. You're starting to.
Yeah, I
answer?
know, I'm, that.
Okay, good. Okay, yeah, I wonder why it was so strange. Okay, glad it works. Paul, are you still having that issue with the vertical beams? Okay, you can try, so I would try maybe restarting space claim, so maybe you can close space claim. Maybe just start a whole new project with the geometry, and then see if that works. I'm gonna try and see if there's anything else here that kind of.
This is my question. When you do this, when you go to the. Cool.
It's so strange because yeah, ANSYS should detect which dimension is the longest, and that should be the direction where it creates the beam. Are we able to kind of restart space claim? Or are you still having the same? Okay. Yeah, keep me updated in the chat and see how things are going. Okay. Every year a new error with ANSYS kind of shows up. Okay, all right. Let me catch up to the class. Just so the connection part can be a little bit challenging.
Having an issue loading the model into the,
So when you double click mechanical, it doesn't load.
so it opens up with the geometries.
Oh,
Which has that question mark.
let me see.
On space plane, it's good.
Okay.
Mechanical when I open it up, it's.
Oh, so you have to close a space thing to kind of save it.
And close also. Mechanical.
Yeah, close mechanical.
Okay. Then refresh, update.
Yeah. Okay, update the gym. Go ahead and double click the model again. Okay, let's do this. So go ahead and close this. Go back into space lane. Save the geometry as like a thing it's called an SDoc file, and then start a new project and you can just import that. Yeah. Thank you. So actually, so you can combine a lot of them. So so what you can do here, I'll go. Yeah. So basically for the road beams, yeah, just control, you can select all of them and we can connect onto the road. Yeah. So it should be okay. Should be okay. I think at the probably at the worst case, we'll probably have to connect these. But all the beams in the road. Like they connect. Yeah, go ahead and open this up. Okay. All right, so if you're able to open up your geometry in mechanical, then it should look like this. Right, so the next part that I mentioned was to make connections in between these, because right now all of these parts are kind of just floating right now, and nothing is connected to anything else. Right, so we need to kind of manually say that these parts are connected, in particular that these parts are bonded to each other. Okay. Oh, first thing. So you remember that kind of mysterious gap that we had in our model? So that's actually like an open sketch that this person kind of left in the CAD file. So this can happen sometimes. So since this little part of the model here is not going to contribute to the structure, we're just going to go ahead and suppress it. Okay. So right click on this sys/surface and go ahead and suppress it. Okay. So that's going to get rid of that body, and then now we can mesh it just fine. Okay. So for your midterm projects, there should be nothing like that in your midterm project geometries, but there might be some screws, there might be some bolts that are going to be really difficult to mesh. And so those are examples of parts where you may want to suppress them, just to kind of give you an easier time with the mesh. Okay. Okay. So the main thing we have to do here is we have to add connections between all the parts. And so to add a connection, you're going to right click on connection here and you're going to insert. And what you're going to insert is what's called a manual contact region. Okay. And so with this, you can see here that there are two areas here. So we need to specify what's called a contact, another what's called a target. Okay. And we need to specify sections of our geometry that are supposed to be connecting to each other. Okay. So for example, I'll do the first one with you guys. So the first one we need to connect is we need to make sure the road is connected to all of the beams below it. Okay. And so for the road, you're going to go ahead and click on the road itself. Okay. So that's you're going to click on that. And since it's a shell surface, we can just click on the top. Okay. All right. So go ahead and set that as the contact. Okay. Right. And so that's you should see one face there. And then for the target, you're going to select all the beams underneath. So since this road is connected to all 7 of those beams, or I think there's might be 8 of them, we're going to select all 7 of these. And if you're having trouble just selecting the beams, make sure you can change it to edge selector mode up here. Okay. So we're going to click on each of these beams down here. All right, so with all, I think that's 7 of those beams selected, go ahead and set that as the target. Okay. Right. And so what we basically just said is that these 2 parts that we've highlighted, that we specified in this contact region, are going to be bonded together. So, you know, they're not going to clip past each other. They're going to actually structurally support each other. Okay. But you can see here that after we've selected these 2, that, you know, these areas here are still yellow. And so if you see a yellow area within ANSYS, that means that, you know, you've either set something up incorrectly or ANSYS wants you to set something else. Okay. And so the issue with this is actually the order in which we specify this. So, you know, there is actually a difference between what is the contact and what's the target. And so generally speaking, when you set these things, you want to make sure that the target surface or the target part of the geometry is the one that's bigger. Bigger or wider or something like that, okay? Mathematically, it's because, you know, when you have contact between different parts, you know, you have to kind of specify which part is going to be contacting the other one. That's just kind of mathematically how it works. And so that's kind of why these 2 settings are like this, okay? We actually need to swap these. And so we need to make sure that the road is actually on the bottom and all the beams are on the top. And so luckily there's an easy way to do this. And so if you right click on your contact, there is a setting here called flip contact / target. And so it'll kind of swap those 2 so you don't have to re-click anything. Okay. And so there we've swapped it so that now the road is the target and the beams are the contact. Okay. And that kind of fixed our error. Okay. Okay. So you need to make a few more contact regions because we need to make sure that everything here is connected. Okay. So to add another contact region, you're going to right click on contacts here, insert manual contact region. Okay. So you want to set a contact region for the edge of the road and the bridge. Okay. So you're going to set the one thing here to be the edge of this road. It'll be a little bit difficult to click because you want to make sure you just get that edge. All right, so let's go ahead and set that as the contact. And then what we want this connected to is we want to connect to the side of the bridge. So go ahead and click on the surface here. Set that as the target. Okay, so that's a valid contact, so that's all green. And you're going to do the same thing on the other side. So you want to make sure the other side of the road is connected to the bridge. Okay. The other contacts that you have to make sure to do is you want to make sure that all of the ends of the beams are connected to the bridge as well. Okay. Now this one's a little bit tricky because when you select the beams here and connect it to the bridge, you only want to select just the ends of the beams. Okay. Let me go ahead and show you. So you're going to right click on contacts here, insert manual contact region. Let's go ahead and select the side of the bridge just because we're gonna need that one. Okay. So I'm going to select that entire surface right there, set that as the target. Okay. And then for the contact, we just want actually just the ends of the beam. And so go ahead and switch the selection mode to vertex. You're going to select each individual edge of each individual end of the beam itself. Okay, which should just be a point. These are just one-dimensional beams. Doing this a little bit quickly, I might misclick something, but you know, just kind of make sure you grab all of them and make sure to hold control on your keyboard to select multiple things at once. Okay. And don't forget the beam up top too. So the beam up top needs to also be connected as well. Okay. And so you should have 8 vertices there. So that should be the 8 ends of the beams. Okay. And you should see that up here as well. Okay, so you should have 5 contacts here. So you should have a road that's connected to the beams, the road connected to each side of the bridge, left and right, and each of the ends of the beam connected to the bridge, left and right as well. So you should have 5 overall. So I did 3 here. That's because I didn't do the other side for the beams and the row. Okay. Okay, so once you have that done, we are just about out of time. We only have 20 minutes left, so I just want to make sure I go through everything. So you can go ahead and finish that up. Okay. Next 2 parts here are just the meshing and the boundary conditions, and so you guys you guys are experts at doing that. Okay. Analysis results. Part 5 of this activity is I want you to do a mesh convergence test, and so remember we've been talking about that for the last couple of lectures, and so go ahead and run that for this geometry here. Okay. Part 6, I want you to change one of the support conditions, so I'm going to change the boundary condition for that. Part 7 here is I want you to redo this activity, but I don't want you to convert it to shells and beams. So just work with the original geometry, and you're going to try to do it. Now, warning for part 7 here, and so this geometry I picked it for the reason where it's not supposed to work well with solid elements, and so if you're not even able to mesh, that's fine. That's actually the exact intended consequence. For some reason there are some computers out there that you can actually get a mesh and you can get results. If you can, that's great. But if you can't get a mesh and it gives you an error, then that's kind of exactly what I wanted you to get from this part. So, and then problem 8 is just summarizing your findings. Okay. Okay, so I know that was really fast, but just the most important thing is just you make sure you set the connection. From there, it's pretty kind of standard stuff. And there are screenshots here to help you out. If you're still having trouble with the geometry, just kind of raise your hand or drop something in the chat. And I want to make sure that everyone kind of gets at least is able to get the ANSYS mechanical by the end of today. Okay. So if you're having trouble, just raise your hand, and I'll come around.
So I did, as you mentioned, so
Okay.
that
Yeah.
problem is it's inflated the connections.
Yeah, you're supposed to add the connections in. So,
Yes, but the thing is, I don't have to do the answer and whatever. Those
Um,
are the errors.
I'll go ahead and select manual contact. Okay. And then go ahead and let's connect the road. Let's go ahead and click the road. Okay, so that is the target. Yes. And then change it to edge selection.
Just the edge and that base.
Edge. Okay. And go ahead and select all the bottom again.
Control.
Yeah.
So why is that?
Okay.
And
That looks good.
then we connect the road and the beams.
Yes, so the road has to be connected to the side of the bridge. And so that should be the method for the right edge of that road and the bridge itself. So that's the edge I would set that as a contact, which is the target.
So can we do multiple?
Yeah, so you can right click on the contact.
That's it.
Yeah, insert it. Yep.
So contact is going to be.
Well, you want it for the contact, you want to set that to be the side of the road.
So you're talking about these.
But like in the
So the
I just want
a
to.
little bit hard to click. See the road. Yes. That. Just the side of the road.
So then by tomorrow.
Perfect.
Oh, no, I'm wasn't telling you to not meshing.
Yeah, so you want to, I would click on this. We're gonna click on
Once
that.
you get it, you're like, all right.
So that's.
Um,
Yes. Yep, and then the target, you're going to select the surface of the sheet. Select
This.
Yep.
I guess the face.
Yep.
That's the other side.
Yep, other side is the duke, and then we want to make sure all the ends of the beams are connected.
And then it's going to be the target will be the road, and then the contact will be the beams
Yes.
without.
Yes. Yeah, so it matters which ones you said is the contact and you want want to swap this, because the target is whichever is the bigger.
Yeah.
And so you can right with this. And then flip on that target. Yep.
So I tried to but the post
Yeah.
side, but even if I put the inside, it's like is that normal?
Yeah, because they're your fixed supports, I'm guessing, are near the bottom.
Yes.
And so the bottom is gonna be much more stable, that's where the fixed supports, but there's nothing really fixing the top. So if you apply a wind force, it's gonna be defined. So, yeah, this looks pretty good. Okay. Yep. Mhm. Yep. Mhm. Yeah. Yeah, you wanna make sure you get the top one too.
Oh, in the top.
Yeah.
Okay, and then.
Exactly.
Okay.
Yep. Mhm.
Thank you.
Very
Does
good.
that vision work? So. And I started like that.
Let's see.
Okay, yeah, give it a. give it a try.
And I'm like, no, I need
Yeah.
to mark.
Right, so what I was, he was having some, so if you're able to. With the shells and things, you can save just the shell, you file the test off, and then you can transport that file to your computer, and you can then do the analysis. Yeah, I want to make sure you get the shell.
Okay.
So. Yep. Oh, okay, so you can't do a method on the email, so they changed that. So there's only one shit for. And I think automatically we should. Yeah, don't allow them to. Just change the size. Yeah, okay. Yeah, but for the method, you actually select the whole one. They changed that just this year. No, that's back there. Should be okay.
Yes.
Okay. Yeah, sorry about that, Paul. Yeah, I think some of the home versions of spacing given that same. But yeah, give it a try on the. Yeah, I don't know if it's something with, because I'm guessing you're using 5.5 student ANSYS.
Yeah.
Okay, yeah, I think someone in the class was also having issues with 1.5. Yeah, I don't know if they changed something or if there's like a bug in how they extract, but yeah, I've never seen that issue where the beans extracted vertically. I can understand why they will do that, just because it's a constant cross section in that direction, but that's, obviously not what we want to do. So, yeah, give it a try tomorrow, and then if you're still having issues with it, just send me an email. I think probably what I can do is I can probably create a geometry and then send you just the geometry. Because a couple other people had to do that today.
They work there too.
Yeah. Mhm.
Yeah, so we have to have a W. J and then it's. Yeah, no problem with this.
Okay. Yeah, I don't know if it's for 2020. I think that the ones here are 2024.
Yeah.
It might be something with 2020. Okay.
Sunday. Like, yeah. I'm just thinking, but worry about it, I think it's. They should take a quiz. No, you can get a quarter. Or just within. You're supposed to get through. Which one is it? Yep. I'm the best. If it's asking us to look again. I'm just not. It's not having a division. It's like. Oh.
So question, the target is supposed to be the larger object. So when
Exactly.
we're connecting the road to the bridge, which one is the target and which one is the contact?
So for the road, you just want to actually just get the left, get one of the edges of the road.
Okay,
And so since that's just an edge compared to a surface, then the bridge would be the bigger.
gotcha. Okay, just making sure I did it correctly. Thank you.
You guys have a good weekend.
Down, she says we arc that down, we arc that thing, and then you don't see it. Which one is that? You open it. I think it's.
Yeah. Okay.
Is it this one that I need to open it?
Yes, it should be the W. So did you archive it?
Yeah.
Okay, yeah, so when you, so when you save, you archive it, then yeah, the archive files will be transferred.
So the PV.
Exactly,
Okay.
yeah.
Oh.
It's good to have it as a reference. Yeah, because it's not like you're looking at it. I do it, and then I see it, and then if I have double, then I go back and it's my previous examples. Let's see, on the week. I don't have weekends anymore. That was for my graduation for that's fine. Huh? Because then I have to take another 4 classes and then 1 3 and then I'm like, no. I'm already dying. I'm already
That's a
dying.
good question.
Sure, what's up?
So when you save them in that.
And I feel tired.
Yeah.
I know, and it's only 3.
Yeah. So what you're gonna do when you bring it home,
Yeah.
just double click it and then it should open up with
It's really
it.
quick.
So, but if that doesn't work, just open up
I wanna
Workbench and
keep
just
it
say
in
import from
I
archives.
just wanna
Just select that.
not comment.
Okay, because last time I did that, it was, started saving.
Yeah,
And so, I started all over.
Yeah.
And it created a
EJ, yeah.
Yeah, I started working off that.
Okay.
The archive didn't work for me.
Oh, okay.
What the issue was,
Well, the archive, it's basically a zip version of the whole project, so it's probably gonna unzip and create those files. Because actually, if you look on the project directory here, like it actually saved quite a few files for our project. That's probably what it was doing. So I would probably put it, the way I do it is I usually put it in its own folder, and then I put the zip file in there and open it.
Yeah.
Creates all.
So you were like trying to catch
I
up.
put my desktop and then.
Ah,
That's what happened.
yeah.
Okay, so now I know.
Thank you. Yep.
All right, see you. See you Saturday.
You Saturday.
Saturday, yeah, right.
Yeah. After 9. maybe 8. Oh,
The-
I'm gonna say.
Yeah, so whichever you set as the target is gonna be the bigger of those two surfaces, so. So the side of the bridge, that would be the target, and then the
I told you people
Um,
mine. I already knew you were gonna get
and
it.
then the edge of the road, that would be the contact. Yeah, so in that case, you're making
We don't
a
believe in ourselves.
edge and a surface, and so the surface in that case would be the target, and then the edge would be the contact.
You didn't want to do
I'm just scared.
because you don't want to like fix it. I get that. Like tell them you get their hopes up and out and on, need to go back or like that.
Yes, like,
Yeah.
it sounds.
Oh,
Not edge,
Yeah.
for sure, but like.
Could you see the
and
contract?
try to see the-
Guys, yeah, all you gotta do is not sign. Just read it, it's like, don't read it. If
Yeah,
there's something you want them to like look into, edit.
yeah.
Don't.
Hello, Professor. Can you hear me?
Yeah, I can hear you.
So even though I'm placing the contact on there for the connections, there's still like a visible gap. Is that supposed to still be there after placing the connections between the road and the bridge?
Would you say a visual what?
There's like a gap between the road and the bridge.
Oh, there's a gap still. Oh, okay, so in that case, you would need to take the geometry back into space claim and then just make sure you extend that road.
Oh, okay. Thank you.
Oh. So the road should be mostly connected there. So you can see here from this geometry, the road should be making contact with the edge of the bridge. So yeah, it was a little bit disjointed. I kind of had to go around kind of help people, but after we extended the beams, like you had to actually move the road down and extend the road to make contact with the bridge.
Oh, actually, I didn't extend the road. Okay, that makes sense now.
Yeah, so you need to go back in space time and extend that, and then we should be able to make the contact.
Okay, thank you.
Yeah.
How you doing, Riza?
I'm gonna try to save it first
Okay.
and then see if I can work on it here. So
Sounds good.
continue.
Yeah. Yeah, so if the archive doesn't work, you can also just save the geometry file itself. But try saving the
Okay.
archive, 'cause that would be ideal. Zoom people, any final questions before I close the call?
Not at the moment. Thank you. Have a nice
Okay.
weekend.
Have a good weekend, everybody.